So the question that we've got here, the last one, is about the last bullet point on the cooling slide about fan cooling or convection cooling versus contrasting that with just static air cooling. And Lee, would you want to comment on that?
Just that when convection cooling is done, the process happens much more rapidly than when it is left to atmospheric cooling. And I haven't found any journal articles that describe a difference in the ultimate flavor of the bread as a result. Maybe Andrew, do you have any? So all I can say about that is that obviously with convection cooling, the cooling process will happen much more rapidly.
So the question is really the FODMAPs. Do extended fermentation times reduce the severity in wheat products? So this is really, really interesting because so there is some evidence, and I know this from my own experience, that long fermentations using natural starters, that some folks who say to me that they're gluten intolerant, non-celiac gluten intolerant, do then respond better. They're able to maybe eat a small amount of those types of breads, and but similarly, there are enzymes that are there in the long fermentations which could break down some of these components, and so that it's not entirely clear whether or not it's those components, their breakdown, or the breakdown of for example, gliadins, which provides, I think, evidential, benefits that have been shown through evidence to help people that seem to react badly to wheat. So I think that last answer sort of answers the second question as well. So I think I covered the FODMAPs. I think that they're broken down partially, and I'd love to see some documented evidence of this. But at least from first principles, there's so much enzymatic activity that's created by the lactobacilli, and they've got cellulases, and they have proteases, and they have their own amylases and maltases and things that I can't imagine that they're not able to break down some of these FODMAPs. Interestingly, because some of those lactobacilli, we now know from more recent evidence, are native inhabitants of mammalian guts. So if we're able to break them down in our gut, we ferment them in the gut, it's quite probable that they're going to ferment similarly and break down those materials in a sourdough. So I'm going to go to the next question. Could you comment on the role of diastatic malt in naturally leavened breads? White bread maker's flour, then I would want some malted barley flour in there to produce fermentable sugars, because the lactobacilli and the wild yeast still need a source of fermentable sugars for their fermentation action. In terms of specifically the use of low diastatic versus high diastatic, personally I have no experience in dealing with this. Most flour millers would correct the flour to a specific falling number at the mill, and then so if they were using low diastatic, they would simply have to add more to get to the same end point. And others might want to chime in who know better than me about the difference between low and high diastatic malts in that regard, but I've got to just step away from that one because I don't know the answer. Okay, so interestingly, so this is a question from Jennifer Baker. Hi Jennifer, hope you're doing well. I've heard two different ways of dealing with this. So from a kind of really technical point of view, once the bread temperature reaches around, and others can tell me what the temperature is in Fahrenheit, so it's around 200 Fahrenheit, I know that's around 92 Celsius, that the starch is completely cooked. But that doesn't necessarily say that the bread is completely baked to your satisfaction. So I know some baking instructors who talk about using a temperature probe to tell when the bread is completely baked. Sorry, it's been a long time for us as well. And but then talking to other baking instructors of long experience and who suggest that you still need to really, once you get to that internal temperature, that they're probably only baked about 2/3 of the way to a full bake. And so, you know, the temperature of the interior is coming up faster than, for example, what you need to develop your full crumb flavour and aroma. So I still think that there is some craft and interpretation involved to say when your loaf of bread that you want to make is at its optimum to come out of the oven. If you're to mill your own flour, what test is important? That's a really interesting one, because I don't know that there are, so I don't know what scale we're thinking about here, but if I was growing my own wheat in my backyard and I threshed that out and I put it in my stone mill, you know, if you're in the absence of all these other fancy tests and things like that, my best estimate is that you should make some bread with it. I know that that sounds facile and that it's not, because even in the world of industrial bread making, we can do all of the predictions that we want, but when push comes to shove to know whether this lot of wheat or this lot of flour makes good bread, you have to make bread out of it. So if you've got the opportunity, for example, to do a small test bake, so if I'm thinking for like home baker, maybe local grain sourcing and things like that, if you're able to do a small test bake, a small scale bake, and you know, with some sort of standardized protocol, and then work out, okay, it absorbs a lot more water than last week's or last year's, or it absorbs a lot less, or the dough was really slack and unhandleable. As an experienced baker, you're going to know about ways of addressing those issues. So, for example, your volume's really low. Then, if the volume's really low in comparison to what you're used to, for example, it may be that the protein content is simply too low to make a well-risen loaf of bread, and there's not much way you can get around that. I would highly recommend making really beautiful whole grain pita bread out of that, because it's probably going to be lovely. Sorry. But in the absence of predictors, test baking is actually probably your best bet, in my view. Have the types of glidance changed in modern wheats? So William Davis in Wheat Belly said that glidins didn't even exist, that they're a new protein. It's nonsense. I could use stronger language, but I'll leave it at that because this is being recorded. Glidins, there are glidins in einkorn and emmer and spelt and durum and khorasan and kamut. They're there. They've been there for millennia. I don't think that now there is evidence from a Dutch group that there's an increase in the frequency of one of the gliadin proteins, which happens to be one that's the most potent in triggering celiac disease. That paper is really easily disputed in terms of where they got their quote-unquote modern wheats from. It was from a single wheat breeding program in Germany. Short answer is I think the jury is out, but my gut sense is that the glidins themselves haven't changed in modern wheats. Okay, do you want to talk about the significant effect of, is there a significant effect of convection fan on oven spring by forming a pellicle or for other reasons?
The effect of a convection fan would be to bring about the oven spring that otherwise would occur, but bring it about more rapidly.
So Troy, that's a really, really interesting question. So there's more than just, so yeah, pH is just one way of looking at acidity. So if we're just thinking about, so there's another way of measuring acidity, and it's called titratable acidity, and it's somewhat more attuned to the way we perceive acidity in our mouths. And also there's a difference in the tartness of acetic versus lactic acid. So at the same pH, you can have a huge variation in the ratio of lactic to acetic, and that's definitely going to drive differences in flavour and aroma, or particularly flavour, this sour taste. And so, and I'd read a really wonderful paper that looked at Italian sourdoughs, and they looked at, you know, and across a pH, now this is just the starter itself, so the pH was about 3.9, but the titratable acidity was like over a range of about a decade in terms of the lowest to the highest, and so there can be huge differences. The thing that we forget about pH that Lee did bring up is that it's a log scale, so the difference of difference of pH of 1 is a 10x difference in acidity. And so, but that, you know, the composition of which acids is really important. I actually think that I can't remember what the target is for corrected flours, because I don't do it myself very often. But the presence of the amylase, and this is a really interesting point about using added sugar versus using enzymes. And so in terms of supporting a longer fermentation, the enzymes recycle. And so what happens with that is an amylase will cut, for example, let's talk about beta amylase. It cuts a maltose unit, 2-glucose, off the end of a starch molecule, and that maltose gets released from the enzyme and, you know, gobbled up by a yeast or a lactobacillus, and the enzyme is then free to create more fermentable sugar. So in a sort of hypothetical sense, if you're just relying on added sugars for a long fermentation, the fermentation organisms could conceivably run out of fermentable sugars. And but the enzymes keep recycling, so they continue to deliver fermentable sugars for the entire process until they're heat inactivated in the oven. And that's the end of that one. Okay. Can I comment on the balance of dough extensibility and strength to achieve maximum loaf rise? Whew. It really depends on a lot of things. So let's take the same flour. Let's say that I just bought some, I can't remember, is it Sir Galahad? I'm not trying to advertise anyone, but we had the specs there. The hard red winter flour from King Arthur. And I use that to make, because it's pretty flexible, and I use that to make a variety of products from bagels to ciabatta. So in the bagels, I've got a different need for a balance of extensibility and strength, but the dough is much stiffer because the water the water addition there is maybe, I don't know, 60% or even less to make that really stiff dough that breaks mixes. Whereas in ciabatta, where I'm using a 90% or an 85% hydration, and maybe not quite that high, but depending on how sloppy you want it to be, to start with, so I can change the balance between extensibility and strength actually by changing the amount of water that's in the dough. But then if I, for example, thought that I didn't have enough strength compared to extensibility in making my bagels, I could, for example, go to a high gluten flour, which should have more strength and maybe less extensibility. But it's a contextual question, and I don't have an absolute answer. Oh, wow. 5, 6 questions. Okay. I'm going to start with number 1. Is there an advantage to maintaining starters from rye and white and whole wheat? There are others who would be better at answering this question than me in terms of practical bakers who do this on a day-to-day basis. So I've got some experience and I use natural starters all the time. My take on that is that I keep one starter as my mother, my base, and it's based on basically this formulation. It's 50% hydration, it's 90% baker's flour, and it's 10% rye. And then I divert that. So if I want a rye starter, I'll break some of that off and I'll feed it with rye over a period of a few days. And to me, it becomes a rye starter. It changes in character, other than the fact it's got all rye flour in it now, but it becomes much more intensely tart and acidic. And similarly, if I want liquid starters, I'll take some of my basic wheat white starter and I'll feed it at 100% hydration. And so my feeling is that you can divert a basic culture into a number of different starters as you need them, but it takes a few days to really get the character of the new starter. So I'm going to look at the questions again. Any advantage to pre-mix the dough while waiting for the levain to mature? I have no idea. So Lee suggests he has no idea either. I guess the The only thing that I could suggest there is if you were using an autolyse or an autolyse, that you could have that concurrent with the maturing of the starter. Can I slow the first or second rise to fit with my outside work schedule? I guess so. I do it all the time. So a lot of times I have to have bread ready for morning classes or demonstrations or whatever, and so I slow my second rise okay, so primarily I slow my second rise. So I ferment the dough, I pre-shape it, I shape it, I put it into baskets, and I retard that. And so that fits my schedule. Other times, particularly with things like ciabatta, where they're hard to handle, I will bulk ferment at 40 degrees to 50 degrees Fahrenheit. I'm a little limited with my walk-in cooler, so it tends to be more at 40 than 50. And that fits my schedule and also makes that wet dough easier to handle in the morning. Although you need to warm it up a bit. So there are definite ways of slowing that down, but really temperature is your only item there, because you don't want to add more salt to slow it down, because it would just be too salty. Okay, so the idea that 40 degrees Fahrenheit puts the yeast into hibernation, I've not experienced that. I get great oven spring coming out of a 40 degree retard. Maybe I'll give it an hour to warm up before I put it in the oven. The evidence of using at least commercial yeasts of Peter Reinhardt's advocacy for the pain à la ancienne, cold 40 degree fermentation, 40 degree water, 40 degree flour, suggests that the yeasts don't hibernate. They go slower, so you get some other advantages in terms of flavour development, but then they wake up. So, can one add too much water to the initial mix? I guess you might want to clarify that. How much water you put into the initial mix is dependent on what the product is that you want to get out at the end. But there is a school that suggests that, for example, if you're making ciabatta, that there's a double hydration that you can do. So some baking instructors will advocate this double hydration, so that their feeling is that if you add all of the water at the beginning, that it takes too long to get enough dough development out of the mixer. So that you can, for example, mix it at maybe a standard baguette style hydration of like 65%, develop the gluten to the extent that you're happy with, and then feed in the rest of the water in this double hydration. Okay, so how does one achieve maximum extensibility? Can I think about that one for a second? Yeah, so Leah suggested glutathione, which is an additive that you can add that breaks up the cross-linking structure. I was trying to think of something that was a non-additive way.
Dead yeast.
Dead yeast. So Leah's reminded me that I can get the glutathione from dead yeast cells. And so you have natural products that you can use to maximize the extensibility. You can try adding more water. That certainly increases the extensibility, but I'll try to come back to that one. Can you give serious home bakers 2 to 3 tips for making consistently great bread? So Lee says practice, 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 and because that's his 3 things. Mine are weigh everything. If you said consistently great bread. So if you're still using that archaic measurement system based on 3 barleycorns, then I would highly recommend not using cups and spoons and ladles and whatever else it is, but get yourself a scale and do it using the baker's percent ratios. So you can do that in whole ounces or whole pounds, but the metric system is probably a little bit more flexible in terms of the weights that you can, the range of weights you can use. So that's practice, weigh everything, and I'll think of a third one. How far can retarding be pushed? So I've tried this. There's a book out called Artisan Bread in 5 Minutes a Day. And basically you make dough and you put it in the fridge and then you chop off a piece every time you want to make bread. What happens, even with enzymes, is eventually you run out of reducing sugars. And so It doesn't really show up in the fermentation because there seems to be enough gassing power there, but the bread does not turn brown in the oven. It's remarkable. You should leave some dough in the fridge for about 5 or 6 days. And it's remarkable that when you bake that off, you basically end up with something that feels like a crust, but doesn't look like it. So maybe that's how far you can push retarding. Okay, so Peter, how do we need to be concerned about hexanol? So I'm not, can you maybe try and clarify that for me, because I'm not sure where you're coming from. Suzanne. Okay, does there need to be a minimum quantity of starter remaining after each discard to keep the yeast alive? Do you use the same, do you toss some starter each time you feed? Yeah, so if I'm feeding in the absence of using the balance of the starter to bake, to put into a dough, then yes, it does get discarded. And I think that there are guidelines probably in the archives of the guild somewhere, in breadlines or something like that, that would tell you. But, you know, I just want to make sure that there's some. So sometimes, for example, if I've been keeping my starter in the fridge, which I know is anathema to some people, because it develops some sort of fridgy flavours, I'll just use 10 baker's percent or even 5 baker's percent of my old starter to reconstitute the starter and bring it up to scratch. And it seems that even if you use very, very tiny amounts of your mother starter to refeed, that in fact there's enough. The proportions of yeast and lactobacilli in there are still the same, and so it will still eventually come back. If any of you have or have access to Andrew Whiteley's Bread Matters book, he's got a chapter in there about care and feeding of starters for the home baker specifically. And it's probably the most lucid exposition of that I've read, and I'd highly recommend it. What are common mistakes that bakers make that the knowledge of science can correct? I'm going to let Lee answer a question.
Hi. So my answer to that question would be this. I think that in the end, bread baking is both an art and a science. And I think that the successful that the baker can be more successful in practicing his or her art with a background knowledge of the science that underlies baking. I think we covered the fundamentals in the course here today. And I think it really is a matter of thinking about those fundamentals as one practices and practices and practices. Every time, certainly, that I bake bread, I try to apply those scientific fundamentals and then watch what happens and try to figure out, okay, what part of the art didn't I get right? So my thought would be that just think about what we talked about today as you continue to bake bread.
Although the question is, what kind of mistakes might this knowledge of science help? So I guess like knowing that you shouldn't add too much diastatic malt, because you know that diastatic malt has a really powerful impact. And so knowing that diastatic malt has such a powerful impact on the structure of the bread, that might be somewhere that you could go.
So can I just jump in? Just on the issue of diastatic malt, the reason it's called diastatic is because it breaks the ester bonds that are in the glucose chains. And I just add that so that you'll understand where that word comes from.
Okay, so I'm going to talk to Brittany's question. There isn't much detail about the staling process. Now, the staling process, in my view, is based on this recrystallization of the amylopectin. Now, if you want to get out into the world of commercial baking, there are enzymes that you can buy that will basically break down just the part of amylopectin, or amylopectin, that recrystallizes, and so you can keep the bread quote unquote fresh, or at least it won't get harder for weeks at a time. For me, staling happens, and it's just it's a natural process, and we're better off living with it. I do, in my humble opinion, think that breads that are made with natural starters stale slightly slower. And there's issues there related to water holding. So the bugs, microbes, maybe a better way of describing it, in particularly the bacteria, some of them actually produce new fiber components in situ as capsules around their cells. And these extra fiber components are related to improved water holding capacity. And so, probably if it hasn't come across already, I'm a strong advocate for the use of natural starters from all sorts of reasons, flavour and aroma, and texture being part of them. But there's also some not well documented effects on staling. Okay, so I tend to store mine in non-reactive containers with a lid, not just a paper towel. Something to stop it's like having a dough. You just don't want the surface to dry out, because it's just a waste. If I refrigerate it for a few days, definitely not in contact with the dry air from the refrigerator. So my experience is that dough needs to have some level of development before it's retarded. So my only way I can talk to that is that in terms of like bulk retarding, or retarding the bulk fermentation, is that it should have had a couple of folds before it goes in to the into the retarder or into the cold room. I've just got no experience with putting doughs in that have less development than that. So, as I mentioned before, my personal I guess just my need in terms of retarding has been to retard fully shaped loaves, and so all of the development that I want has happened. My experience with comparing natural leavened breads with yeast leavened breads is that somehow the acidity helps the retarding process, that the doughs are less likely to fail when they come out and are put in the oven, but I don't have documented evidence of that. So if actually the question about non-celiac gluten sensitivity, and so it would be more correctly termed now, if it's not gluten, non-celiac wheat sensitivity, because it may not be the gluten. So if you go onto the Bread Bakers Guild forum, Alan Cohn from Southern California has put a link up to the article that was the article that, at least in the media, that came out related to the papers, and that will direct you where you need to go. But that link is on, or at least in the archives of the Bread Bakers Guild online forum. Any guidelines for converting recipes from fresh commercial yeast to natural yeasts? You would have to ask a much better baker than I on that. I've tried it where I, for example, have been raising things with a pouliche to go to an equal weight of a liquid starter, a 100% hydration levain, with moderate success. There seems to be less gassing power, but in general, the natural starters aren't as vigorous in that, and so there's a different outcome depending on what you want. So I'm sorry, I don't have any hard and fast guidelines on that conversion. Okay, so Mick, the yeast most yeasts are pretty intolerant of heat, and in fact will probably die just slightly after 40 degrees Celsius. So once they're past 60, they're certainly almost all killed. And so there's no residual yeast or fermentation activity going on in the bread. So let me look at the rest of that question. Most resources say the yeast dies off at 60. So I guess the short answer is yes, the yeast does die off. You know, I think because Kathy can let you know how to contact me by email, I can talk to you about that asynchronously to this, because I might be able to direct you to some documentation of that question. Okay, so yeah, I think we're towards the end of our session here. I'm really appreciative of all of the questions and the fact that you guys have hung around for this long. It's really amazing, and I hope that the guilds are really happy with the outcome. We've had a couple of nice comments there in amongst the questions, and I appreciate those as well.
So I'd like to add my thanks to everybody who participated in this webinar. It is the Guild's, as I mentioned earlier, the Guild's first webinar. I'm hopeful that this will prove to be a means of communication that